I'm Maggie Zirnhelt, and I'm so excited to welcome you today to this talk, Joining Jamf Threat Labs, A Day in the Life. I joined the macOS Threat Labs team at Jamf 6 months ago, and I'm looking forward to sharing with you some of the things that I've learned during that time. Let's start out by talking about what the Threat Labs team at Jamf is about. So, the Threat Labs team is the team who tirelessly secures macOS, network, and mobile. And we're responsible for keeping the world safe on all of our devices. So today, since I'm here representing the macOS Threat Labs team, we will talk only about the macOS Threat Labs team's processes and tools. Again, this is me. I've been at Jamf for 4 years, and previously I was on the Jamf Protect engineering team, also as Nick mentioned, which is really very helpful, having moved to the Threat Labs team, to have the context of how Jamf Protect's system extension works in detail, so that I know about how to make for the best performance for all of our Threat Labs intelligence that's channeled through the product and onto the endpoints. So that was a great time, and glad to be on the macOS Threat Labs team now. About me on a personal level, I live in Vermont in the US, which is in the northeast part, right up against Canada. And I love it there, but I also really love traveling. And this is my first time in London, and it's really a lovely place. Excited about all the, the sights and the great food and the diversity, so very fun. All right, now that we've been introduced, imagine it's the morning, and we're sitting down at our desk to, first things first, tackle the most important part of the day, which is making sure that all of our customers are protected from the most recent threats on macOS. So we're going to think about spreading any knowledge that we have with the world. We're also going to update ourselves with knowledge that the world has for us. And then we're going to apply all of our new knowledge to Jamf Protect's threat feed. So let's first take a look at updating the world with knowledge that we have. This is an example of a blog that I wrote with some of my macOS Threat Labs colleagues about info stealers, which have been very popular in the past 6 months, unfortunately. And this particular article is about info stealers spread through Google-sponsored ads. So that's an interesting one. I'll give you a link to where you can find this one if you want to read through it. You can see that we take care to include screenshots and code snippets and lots of details about how the malware works after we've dove into it. And then at the end of the blog posts, we include static indicators, which we will talk about shortly. There's also a whole list of other blogs that we have, which you can go check out if you want to, at this link, which I will post again at the end of the presentation, so along with the other links that I'll refer to. So we have looked into spreading knowledge that we have about our research. Let's now go and update our understanding of the threat landscape as it is today by going and looking at news and other research teams' articles that are kind of similar to the one that we just looked at about the info stealers. So we do a little bit of reading, got some favorite sites to go visit. Twitter's pretty good about it. And so now we can consider ourselves up to date, and it's time to apply our new understanding to the actual Jamf Protect threat feed. So this is the face of threat prevention in Jamf Protect. And you can see that the page itself doesn't really have any buttons or anything for you to press. You can see that we've got the dates of when updates have been pushed out. And that's actually just what happens, is you don't have to do anything to apply these updates. You just have to have Jamf Protect on your endpoints, and it will be pushed out and taken care of for you. So there's no concerns about anything that you have to do to make sure that you're up to date. It's just as easy as possible for you to be able to block malicious files from executing on your endpoints, which is the purpose of threat prevention, which is just one piece of Jamf Protect as a whole. So threat prevention, great. This is one of the things that we love most about Jamf Protect, is that we're able to block bad executables from running. So we're going to take a little bit of a dive into what threat prevention updates are actually made up of. But first, we want to get some context about what we're going to need to know before we understand threat prevention updates as a whole. So first, there are two kinds of analysis. One has to do with threat prevention, which is static analysis, which takes a look at a binary without actually executing the binary. The other one has to do with executing the binary, and it's called dynamic analysis. We'll do some dynamic analysis later, but first we're starting with static analysis for threat prevention. All right. In static analysis, we use what are called static indicators, which are things about a file that don't change as we execute it. So some examples of static indicators are developer identifiers, which we will dive into just in a moment to complete our context. We also have file hashes, which are like a file's fingerprint. It's something that's unique per file. Each unique file has its own hash. A file size also is a type of static indicator. We've also got, finally, very importantly also, character sequences that we can find within files, which we call strings. And that's how I'll refer to them as we go along here. So I mentioned that I would kind of tell you about what developer identifiers are. This highlighted is Jamf's developer identifier. A developer identifier is something that someone who wants to write software for macOS is able to go to Apple, pay $100 a year, and receive back a developer identity, which has a developer identifier as a part of the identity. So yeah, $100 a year, you get one of these, and you're able to run your software signed by your identifier, and it will just run on macOS without being blocked or without popping something up to the user that says, this is something that's not signed. You should really be cautious about running this. Having an identifier to sign it will make it so macOS says it's good to go, and it won't cause problems for the user. So we're able to identify bad people as well who are trying to run their software on people's macOS systems, and we can block software based on developer identifiers as well. So you can probably imagine that that's kind of useful in threat prevention, where we're trying to block malicious files. So we'll use Protect's custom prevention view to give ourselves a final and full understanding of what threat prevention updates are really all about. So I mentioned file hashes are like file fingerprints that has a unique hash for each unique file. So we use that, and we have third-party feeds that we use, as well as our news update understanding of malware that's out in the world. So we can use those together for hashes, as well as for developer identifiers, also called signing IDs, as shown here, or team ID, rather. So those are the two ways that we can use threat prevention to block malicious files. There's another aspect of threat prevention that's a bit different, but also has to do with static indicators, and it's called Yara. So Yara can get a little complicated, but I hope that you'll find this to be a fairly simple example. We'll start with, on the top left, you will see a little poem that we're going to refer to as our search text. In malware research, this search text would actually be a malicious file. So yeah, you can imagine that gets longer, and it really becomes a bit of an art to go and find the right pieces of the file to use in this other section, which is the rules on the top right. We've got 3 rules on there. Each one starts with the word rule, and is followed by the name of the rule. Each rule has a set of strings and a condition. The second rule that the cursor is on now has 2 strings. One is in the search text, and the second one is not. And that's what the condition says. So we expect this rule to match. We expect also that the first rule will match. This last rule, though, has a string that is not in the search text, but the condition of the third rule says that the string should be in the search text if the rule is going to match. So we don't expect this last rule to match. We can use the Yara command line utility, which we will use on the bottom part of the screen up here, to check what we think is going to happen. So we'll give the command line utility the rules file and the search text, and we see that those first 2 rules do match, just like we had thought that they should. We can also use the -n flag for the Yara command line utility and see the rules that don't match. And we see that, in fact, that third rule does not match, just like we expected that it should not. So that's what Yara is about. This is another way that we can block files that we identify as malicious. And perhaps you could see through this demo that Yara rules are stronger than just file hashes because, yeah, when there's evolutions of malware, file hashes change, and we're not able to know anything about future file hashes necessarily. But we can know about what previous versions of malware had as their key components, and then we can use those key components in Yara rules so that we can detect malware without knowing anything about it besides what family it belongs to, and what its key indicators are as far as strings, character sequences. So this is another part of Protect that you don't have to go in and do anything about. This just happens for you, gets pushed automatically. We have a large set of Yara rules. We're careful to make sure that they perform well and that they catch all the things that we want to be blocked, and in conjunction with developer identifiers and file hashes individually, we do a pretty thorough job of blocking all the things that are known on the threat landscape at a given time. So that's Yara, and that was threat prevention. Another part of Protect, separate from threat prevention, is what's called behavioral analytics. This is an example of a Jamf managed behavioral analytic. It's called disguised executable. And the part that the mouse is scrolling through now is the predicate, which is a very important part of the analytic. It's the part that the system extension, or daemon, actually uses to give us an alert when a process matches the predicate. There also are types of analytics for files and other things as well. You can see also that it has a description and a remediation suggestion. Back to the predicate for a moment, it says that if a process has a path where the executable ends in .doc, for example, that's strange. And so if there's a match for that, then we're going to get an alert about it in the protect console. And so we'll know that something weird is going on. Someone's trying to disguise their executable. So again, you might, you're probably not tired of hearing this probably, but this is something that Jamf manages for you. And we're able to update this as long as you have the Jamf managed analytics set enabled on whatever plan. We're able to push updates, make sure that all of the analytics that we manage are behaving correctly, and we're able to push out new ones too, as is appropriate. All right, we applied our new knowledge of threat intelligence to our protect customers, and now everybody's safe for the day. So we can move out of doing our threat prevention and behavioral analytic updates into more of a research mode in this afternoon of our day in the life. So we're going to take a look at some tools now that we use on the Protect team, including this one called VirusTotal. This is a community malware database where people can upload and download malware, which sounds crazy, but it's really very useful to get an understanding of what other groups and people identify as malware. And it also allows us to get details about files without having to go and find them individually by ourselves and pass them around, or even download them and analyze them ourselves. So we can just get details through VirusTotal instead, which is what we will do. And we'll start with one that I've chosen already, a piece of malware that we don't know anything about at this point, but we'll go through some analysis of this sample to learn about it and see what it does. First things first about the VirusTotal sample hash page is this big red circle. You see 29 out of 61. That means that 29 out of 61 tracked vendors identify this file as malware. So that's where we're starting with this sample that we're going to be analyzing. And then next, we'll go into the details page and see its hash, which, don't memorize this. I'll point it out to you when it comes up again in a moment. But we'll copy it, and we're going to bring it over to a different tool that we have on the Threat Labs team, which is called Titan. This is Titan. So before we dive in and start our analysis on this sample that we've chosen to revolve our research around, and eventually we'll build an analytic to defend ourselves against this malware that we're analyzing. Let's first talk about what Titan actually is. So you should know Titan is an internal tool and won't be released to the public, but at JNL this year, there's going to be an in-depth talk about Titan by Jaron Bradley and Nick Benyo from my macOS Threat Labs team. So you should see that in person, or you can see it also online if you like. And I'm confident that that will be a very interesting session. So check out their JNUC talk on Titan. Besides that, we can look at it now and get an understanding of it. We see two spheres, where each sphere is composed of groups of dots. Each dot represents a malware file. Each group of dots represents a malware family. So this helps us to see the bigger picture of what it's useful for, which is giving human analysts like us an understanding of relationships between files, and also what it means to be a malware family is kind of represented in Titan with these two different models, which we'll take a little bit of a look at them both. So when we were in VirusTotal, we said we'd come over and start our analysis on that initial sample that we don't know much about now. So once we're done turning Titan around a little bit, because it's just very fun to play with, we'll actually search for that initial sample, find it in the point cloud, and zoom in to see this little group of dots, which represent similar malware files. I press a hotkey to pull up the hashes and some details about these similar samples, and we can see what the hashes are, and we'll choose a similar one and go back to VirusTotal to compare and see how they're similar. Before we leave the screen, though, you can see that most of them are marked as generic or multiverse, which is Microsoft's way of saying generic. But there's one unique name up there, which is atomic steel. So, all right, tuck that away as kind of our first meaningful-ish piece of information about this sample group. So atomic steel. Let's bring that similar sample over to VirusTotal so we can get some details about it. So this is that similar sample from the k-nearest model that we had just clicked into. And here's the start of its VirusTotal page. So we'll have the similar sample from the k-nearest model in the red, and then our original sample in the blue. And we'll just scroll through a bit to see what they have in common. We can see first that they have the same file size, which you may recall we said that file size is a type of static indicator. So, all right, that's a static indicator in common, and indeed, the k-nearest model that we're working with uses static indicators to compare files. So we see that both use terminal.app. Interesting. They both also use AppleScript, which is very interesting. Info stealers do that. They use the system appearance bundle, which is kind of strange. And then the last thing that we'll note is that they both write to a file called sysinfo.txt in a directory that has a short number as a name. So, all right, we're tucking away all of these pieces of information as we go through our analysis of our original sample, which is in the blue. So we've got two things now that are telling us that this might be an info stealer, with the AppleScript part, as well as the atomic steel name of one of the similar samples. So we talked through now that this k-nearest model uses, bless you, static indicators to compare files. What about this other one? Is this other one going to be useful in our goal of writing a custom analytic to defend ourselves against this malware? The name of this other one is ASM tvec, and ASM stands for assembly, which is a type of language. So to better understand whether this model is going to be useful for us right now, let's take a little hop over to this other screen to think about what assembly language is. We're going to start by looking at some regular human-readable, at least relative to ones and zeros and assembly, it's human-readable, this short C file. So keep this in mind as we move through. We'll move over now to a binary analysis tool, which they're all around. You can just Google binary analysis tool if you want one for yourself, or I'll recommend one to you if you ask. And we can go to the disassembly tab and see this assembly language. So this assembly language version of this file looks very different than the C language version of this file. If it's the same file, same code, why does it look so different? We can summarize why they look so different in a few steps, which are here. We start with the human-readable, in this case, C code. And then we move to binary through a process called compilation, which you may be familiar with. It literally means to translate the human-readable code into the binary code. Each compiled language has its own dedicated compiler. Some examples of compiled languages are C, Swift, and Objective-C. But not every language is compiled, like Python, JavaScript, and Perl are not compiled, interpreted instead. But that's a topic for a different day, so we'll move on thinking only about compiled languages for now. So we know at this point that the human-readable code gets translated into binary code. And the binary code is at the level that the computer is able to actually read it and execute it, where a 1 means send off an electric pulse, and a 0 means don't. So this is the computer's level, and then one level above the computer's level is where assembly sits. We can map out groups of bits to assembly instructions. And they're very simple operations that are done in assembly, like moving a value from one place to another, or comparing one value to another. So then, once we know that, we can take another look at some assembly and see that, yeah, we've got like the MOV operation to move the value sitting at this place to this other place. Or we've got sub for subtract this thing from this other thing. So, all right, it perhaps makes a little bit more sense now. But to apply this knowledge to the ASM to VEC model, we can step back and think about if two models have similar assembly code, they have similar functionality. And having the same assembly code means they have the same functionality. So with this ASM to VEC model, we can compare files' behaviors. Pretty powerful, a little complicated for what we're trying to do right now. So we'll move through the rest of the process of looking up our original sample in the ASM to VEC model, and we'll bring it to VirusTotal once more, just briefly. But we're going to use more static indicator, understandable type things to build out our analytic. So we'll pull up the ASM to VEC model and once again go in and search our original sample hash. Shows up in a totally different part of the point cloud in this model, since it's a very different model, and the group looks different too. But with our hotkey, we can pull up that table again of similar sample hashes. And we see again that we've got atomic steel up there among the generic names. So both models say that this info stealer type is similar to the original file that we're working with. So feeling fairly confident at this point that this file we're analyzing is an info stealer. Let's just briefly bring it over to VirusTotal, just to show ourselves for sure that these two files don't necessarily have static indicators in common. So we'll pull up this ASM to VEC similar sample on the red screen, and then we'll move it next to the original one on the blue screen again, and we'll just scroll up a little bit to see that the static indicator of file size is really quite different. So yeah, another confirmation that these two files that are similar by the ASM to VEC model are not similar with static indicators like the k-nearest model showed, but instead they're similar by their code and their functionality. All right, that was enough VirusTotal and Titan for now. Let's move into something a little more exciting, which is actually running the malware and constructing our custom analytic using Jamf Protect to defend ourselves against it. We're going to want to make a plan first, though, so we're not just going and executing malware wherever. So let's think about what steps we need to go through to successfully defend ourselves against the malware. We should note first that this is being done in a virtual environment that's isolated from all of my personal information, so I don't have any things that are sensitive in my virtual machine, and you shouldn't either when you're executing malware, because it will probably get sent back to a malicious author. And of course, you don't want that. So step one is going to be using Apple's tool ESLogger to collect logs about what the malware is doing while we execute it. Step two is going to be using this tool called SpriteTree, which I'll introduce to you, to look through the logs in kind of a nice way, I think. Step three, we'll use SpriteTree to identify something that the malware did that will be nice to use for our custom analytic. Step four will be actually creating and deploying the analytic. And then finally, step five will be testing it out and seeing an alert in the Protect console, which will be pretty satisfying after all of this analysis we've done. So we said, first, we want to use Apple's tool ESLogger to collect information about what events the malware generates when it runs. So we'll use these events that have to do with what SpriteTree can ingest, and we'll put it into this infostealer.json file. And then we'll come over. It's time to run the malware for the first time. So we're going to right-click to open to get our own gatekeeper. And we saw the terminal, or a terminal window popped up, which was a little strange. So it looked like it did something. And then also, we see a file that has this certain length of number name, and turns out it's a directory. And it has sysinfo.txt within it. And the sysinfo.txt file has some sensitive information, or it would be sensitive if I had not been doing it in an isolated environment. So looks like we were right that this is an info stealer. Definitely the malware has done some things at this point, so we can stop collecting logs and move over into this tool, SpriteTree. Before we load in our log information to SpriteTree, I'll just give you a brief introduction to it. It was created by Jaron Bradley, manager of the Jamf macOS Threat Labs team, our friend Matt Schott, and myself. So I'll give you a link to where you can find this free tool in a moment. But first, I'll just mention to you that it's useful for having a process tree that's a visual way of relating events, specifically that come out of the ESLogger tool in Apple's endpoint security format using their data model. This is the link that you can find it at, and I'll have it up again at the end of the presentation. All right, so time to load in our log information to Sprite Tree so we can see what events happened while the malware was executing and which one we can use to write ourselves a custom analytic. So here's our process tree for what happened while the malware was executing. We can see this hash here, which is our malware's hash, and everything to the right of it is what our malware did. So, all right, did a few interesting things. We can go in and look at the details of the different things, but see, maybe most interestingly to me, at least, is this OSA script command. That's AppleScript. That's the AppleScript binary. So this seems like it'll be a good one to use to write our custom analytic around. OK, successfully completed the step about going and finding a command that the malware executed to write a custom analytic about using Sprite Tree and Apple's ESLogger tool. So let's move now to the step of creating the analytic in Jamf Protect. I wrote it already, and I called it terminal in the background, but let's step through just to see kind of how it's connected to the command that we based it off of. First, we've got the part about AppleScript, OSA script. We'll say that the path of the binary is OSA script. Next, we've got the part about -e, which means the next section of the command will be executed as an AppleScript. After that, we want to say that we should get an alert if this says to tell the terminal something, and that something will be that the window should be set visible to false. All right, so we're at the point now where we've written up our analytic and we've deployed it by checking the box on our plan, which I'm not going to go into detail here about. But then we've also checked that our analytic is now active on our endpoint. And we're ready to run the malware again and see if we get an alert. So we're at the testing phase. All right, hope it works. It's not a live demo, so it's a little less exciting. All right, so running it again definitely did something. Let's go into the Protect console, and yep, we see we got an alert for terminal in the background. And in the Process tab, we can see the command that we detected and alerted upon. So I'd say that we successfully attained our goal of writing a custom analytic to defend ourselves against this malware. And these are the steps that we took. We used Apple's ESLogger tool, Sprite Tree, identified a command to use for a nice analytic. We wrote it up, deployed it, and tested it to see that we got an alert. Our analysis and writing up the analytic paid off. So I would definitely say that that's a successful day in the life of a macOS threat researcher. We made sure that we shared research findings that we've had with the world. updated our knowledge, applied our new knowledge to the Jamf Protect threat feed, and then we went in and did some research ourselves and successfully protected ourselves against this info stealer. And tomorrow we'll apply this analytic to the rest of our fleet. So these are the links that I said that I would share with you for Jamf's macOS Threat Labs blog, as well as Brightree. And that's all. Thanks for joining me.
Thank you. Thank you, Maggie. That was awesome. Thank you
Thanks.
so much.
Thank you.
We have a question from our friend
Okay.
Ricky. Ricky, show yourself, sir. Where are you? Yes. Lovely for you to be here. Ricky asked a question. Do you anticipate Jamf Protect replacing traditional antivirus solutions? And Ricky, feel free. We'll have a roving mic to add a bit of colour to the question as well. Over to you, Maggie. What do you think?
Yeah, definitely.
Hi
It
there.
was almost a rhetorical question, right, Ricky?
Yeah, we're always looking to consolidate our products and agents on our Mac. So just if you anticipate this being another kind of function that we could streamline all our products into one.
Yeah.
Yeah, I would say so.
Indeed. In fact, we're seeing a number of customers. This is a fairly common journey that we're seeing customers go through. There's a lot of talk about agent consolidation, right? A lot of agent bloat on machines that are impairing performance, and that's a very worthy and noble pursuit to consolidate. And I think, hey, you're asking a guy that works for Jamf, right? The sales manager, he's going to say, yes, Ricky, come and see me afterwards.
There's also the fact that Protect does some things that your typical antivirus does not do. Like, it opens up the ability to add on to it if you're a power user and want to defend against things that you determine you don't want your users to do. And there's also behavioral analytics are not a standard part of regular antivirus software, so it's powerful also in that way. And yeah, talk to salespeople for Protect.
Bring your pen,
more.
Ricky. Great. I think that may well be the only question on the app, but we have a few moments. Let's fill it with some questions. Who has the first?
How many people work in your team that do the threat detections?
Sure. On the macOS Threat Labs team, we've got 5.
Would you be kind enough to use the mic? So there's right next to
Oh,
you.
there's one.
Is there a way to submit indicators of compromise if we find things that you can look into?
Yeah, you can talk to your contacts at Jamf to get in touch with the Threat Labs team, and we can work with that. Or in the custom threat prevention section, if that's the type of indicator that you want to block against, you could also use that just for your own fleet. So, yes.
How much time passes from discovery of a new threat for macOS to it being implemented into Jamf Protect and for customers to use?
You say how much time passes?
Yeah, from time of discovery of the new threat to it being deployed to Jamf customers.
Sure. So typically we do updates every day, but there are cases where we do updates multiple times a day as well. So at least every day.
Right now, there's no kind of real DLP in the solution. Is that something that you're intending to build in so we can kind of have a Apple-first DLP solution so we can utilize more features? So in enterprise, we have to block quite a few things. And this would be, something we would be looking forward to.
We've got telemetry set up within Jamf Protect, which definitely has to do with DLP. But I can get you in contact with my product manager, and he'll be able to tell you more and maybe more specifically address your needs. Cool.
That looks like Adam. Do I see Adam? We'll hook you up, Adam.
This all seems very manual when this whole analysis part. I'm here.
Thank you.
Are there any plans to implement AI into this analysis plan?
I'm not sure exactly what to say about that, but I know who will know what to say about that. So come and find me at the end, and I'll get you in touch with the right person.
We're very lucky. We've got a lot of the product team, a lot of the senior leadership team here today. So please, we'll definitely hook you up. Thank you.
Based on your time in Threat Labs, other than using Jamf Protect or another similar product, what one piece of advice would you offer to IT admins to stay secure?
One piece of advice that I would offer to stay secure. I would say get yourself as an admin up to date on just general best security practices and do as much as you can to share your knowledge with your users so that people aren't vulnerable to, I guess basically phishing attacks would be the thing that you would want to avoid most since that's so common. Also just generally trying to get your users to not be subject to the like Google sponsored ad kind of situation. So be careful about downloading and running apps from the internet. So hope that answers your question.
Thank you.
Thanks.
Thank you. We've got time for one more, I think.
Hi. So a lot of the remediation currently gets done through Jamf Pro. Is there any pipeline looking at doing remediation within Protect? Just thinking about customers who perhaps don't use Pro as an MDM and that would just like to use Protect on its own. Also, there's a bit of a time delay with what's happening through the various products, but if there was something you could talk to around remediation directly through the product?
I think that this is another one that I would want to connect you with my product manager about. But I would point out that there's the remediation suggestion existing in Protect, which of course doesn't actually do the remediation. But come and talk to me and I'll get you connected with my product manager.
Maggie, thank you so much. Let's hear it
Thank
from Maggie,
you.
everybody. Thank you.